Very good morning, students. Welcome to IIT NEET, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participants of class 6 for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th. Today we are going to start a new chapter, kinematics, and we are entering to the first session, the first day of the new chapter, chapter number 2, kinematics. So kinematics is the major part of the physics. The 50% of the physics deals with this particular branch only. So it plays very important role in our day-to-day life also. Without this, we cannot even move 1 second also. Such a very important chapter which is applicable in our regular life. So before going for the chapter, let us see exactly what is kinematics and how far it is helpful for us, right? Okay, so this is the chapter, the second chapter, kinematics. You can see the page number 20. You all can clear, this is from your material only. It is from our material, clearly mentioned what is the importance here. Chapter number 2. So before knowing about kinematics, you should know about the mechanics, which is the main part of the branch of physics. Mechanics is the branch of physics which deals with the study of motion. Study of the motion, movement. So, from morning to evening, we cannot do any work without motion. We'll involve with the motion, different types of motions in our day-to-day life. Entire study of the motion is known as mechanics, which is the major physics. Right? And this mechanics is classified into again three categories. One is kinetics. The second one is kinematics. And third one is dynamics. Right? These are the three subparts of the mechanics. See, mechanics is study about the motion, entire motion. How my body is moving, why it is moving, what is the reason behind the movement, and everything, what are the different types, everything comes under mechanics, which is the 50% part of the physics. Major role in a IIT and medical entrance exams. Right? So it plays very important role. Right. So it plays very important role in that again they classify into kinetics. Kinetics is nothing but study of body at rest. When a body is at rest, the study about why it is rest, what kind of force are acting on it. Study of rest is called kinetic. Study of motion without cause. We don't want about the cause, why it is moving. The study of motion of a body is called kinematics. Dynamics is study about the cause of motion. Cause means why body is moving. Cause is force. So to study about the force where Newton's laws of motions comes into place is called dynamics. Like that, the kinematics is the one small part of the mechanics where we discuss about the motion of a body without considering the cause of motion. We are not thinking about why body is moving, why body is not moving. This is not our concern. Our concern is whether body is moving or not. If body is moving, in what way it is moving? Whether it is moving in one direction, two direction, three direction, or circular, anything that we have discussed here. Right? So study about the motion of a body without cause of the motion is called kinematics. You can see here. Mechanics is the branch of physics which deals with the motion of the bodies. So kinematics is the one of the branch of mechanics. It deals with the motion of the bodies. See, motion without considering the cause of motion. In bracket you can write force. Write down this as the first point. Second point. One point here and second point from here. Note down first. Mechanics is a branch of physics which deals with motion of the body. First point, right? Second point, kinematics is the one of the branch of mechanics. I told there are three are there. Mechanics, it deals with the motion of the bodies without considering the cause of motion. Cause means why body is moving. We are not considering. Generally, body is moving because of the force only. So the cause is nothing but force. That is second point. Right? 2 points, note down. First, then we'll come to rest. You know, all rest. You're all sitting and watching the either TV or projector, whatever it may be. Even I am also sitting and teaching. So we are at rest only because we are not moving. Even though you are doing work, you are at rest. What is rest? When a body does not change its position with respect to surrounding of the body is said to be at rest. Example also given. A chair lying on a room is state of rest. Suppose one chair is there or your table is there in school. It is at rest. Even now you are at rest. I am at rest because we are not changing our position. We are here on the same place. I am not just not like your teacher in classroom. Classroom teacher can move here and there while teaching, but I cannot move. If I move, you cannot see me. Right? In virtual class. Right? So I am at rest. You are also at rest. Even though you are sitting and writing in notebook, you are at rest only. Okay? Fourth point, motion. Actually, our main part. That is kinematics. A common characteristic of moving body, they change their position with time. So this is, you can write. A body is said to be in motion or moving when its position changes continuously. When a body changes, for example, you have seen your friend is sitting beside you just 5 minutes before. But after 5 minutes, he moved from there and he sits some other place. After 5 minutes, some other place. So what is the meaning? He is in motion. If a body changes its position with respect to time or time to time, any body is said to be in motion. So just there should be a change in the position of a body along with the time or surrounding, then body is said to be in motion. And study of this particular motion is called our kinematics. Study of motion of a body. Clear? So here we'll discuss not only about motion, we'll discuss about so many types of motions which will come across in our day-to-day life. So many motions we can see, different types of motions that we'll discuss. Right? So an object in motion is one changes its position with respect to surroundings. An object which is at rest does not change the position with the, that is the difference. If it is not changing the position, suppose you forgot your notebook on your table. So next day you came and you found the book there only. Then that is at rest. Morning when you came, book is not there. That is motion, somebody stole it. Correct or not? If there is a change in the position, then body is said to be in motion. If there is no change in the position, body is said to be at rest. So both are connected to each other. Rest and motion are called relative terms. When body is not in motion, it is in rest. If it is in motion, it is not at rest. Right? So we can say that rest and motion are relative terms. So rest is directly proportional to motion, we can say. Why? Because when there is a rest is there, there won't be any motion. Where there is a motion is there, there won't be any rest. When one is there, other is not there. We cannot say, sir, body at rest as well as in motion. So they are relative terms. The rest and motion are relative. An object at rest with respect to observer may not be at rest with respect to the another observer. For example, see, you are standing near the bus stop. A person is going by car. He crosses you. You feel that the person is in motion. But person who is seeing from the car, he feels that you are in motion. That is called the relative term. The same, actually the person, driver who is sitting in car, any passenger, they are not in motion actually. They are at rest only. Car is moving, but they are observed to be a motion. Right? So consider two persons seated in a moving train. For each of them, the others are at rest. With train itself, they are in motion. So actually, they are sitting opposite to each other. So both know that they are at rest only. But with respect to train, they are moving. They are changing the place. They move from one station to another station. They started in Hyderabad, they reach Vijayawada. Without motion, how is possible? Even with respect to Earth, if you see, I am also in motion. Because we know Earth is moving. Always. But with respect to myself, I am at rest. So that's why they are called relative terms, comparing terms. Right? So we learn about what is kinematics. So kinematics is the branch of physics or branch of mechanics which deals with the motion of a body without considering the cause of motion. It's completely kinematics. So rest, with first term in kinematics, rest. When a body is not changing, does not change its position with respect to time, then body is said to be at rest. If a body changes its position from time to time or with respect to surroundings, is called body is in motion, where both body, motion and rest are in the relative terms. They are very connected to each other. They are not independent, right? Now, just to the outlines before going for the one video, we'll see about this. So, different kinds of motions. So, in our day life, from morning to night, we'll see so many types of motions. In that first one is translatory motion. A motion in which all the particles of the body move through same distance at the same time is called translatory motion. See, a bus moving on a road, the motion of the rising, examples, a bus moving on a road, the motion of a rising balloon, the freely fall stone under gravity are the example of translatory motion. So, for example, when you are dropping stone, all the total stone is traveled distance and it touches the ground. When bus is moving, entire bus will move around the same direction, not some part this side, that side. Balloon when he is raising, same, right? They all comes under the translatory motion. Translatory motion is further classified. Again, this is classified into rectilinear, curvilinear. Two types of translatory motion. When it goes straight line, bus is going straight line, that is called rectilinear translatory motion. When bus is taking curved path, that is called curvilinear. Even though it is taking curve, it goes straight only. Curvilinear translatory motion. So, translatory motion is nothing but when all the particles of the body moves in same direction. For example, when you are taking the arrow, when you are arrow with the bow, the arrow will follow same direction and hit the target. That is translatory. Gun, bullet from the gun. That also example. Arrow from bow. Arrow, bullet. They also follow all the particles of the bullet moves in same direction and touch the target. All the particles of arrow goes and touch the target or miss the target, whatever it may be. Or all the particles of bus moving in same road. But in this also there is a difference is there. Whether it is going straight line or it is following the curved path. When it is follow the curved path, that is called curvilinear translatory motion. When it moves straight line, it is called rectilinear translatory motion. When an object moves along straight path, its motion is said to be rectilinear. The marching of soldiers on straight road. They do not march first. No, you also can do during the Independence Day. The motion of the car on straight road. The motion of carom board points are example of rectilinear motion, straight line motion. When an object moves along curved path, its motion is called curvilinear motion. They are translatory only. They both are translatory. Again, there are two types. A bus moving in a flyover bridge. Flyover. A car taking turn. A football kicked from the ground into air. Now, see, when you hit the football, it follows like this to reach the goal. Correct or not? So this is the curvilinear because it's taking some curved path. Clear? So the first type of motion is translatory motion. The motion in which all the particles of the body moving through same distance in same time is called translatory. The translatory may be either they are moving in a straight line or they are moving in a curved path. If they are moving in a straight line, that type of translatory motion is called rectilinear motion. If the body is moving in a curved path, it is called curvilinear motion. Rectilinear, curvilinear are the two types of translatory motions. So like that, there are so many types of motions are there. And with examples, before going for the further, let me show you one video on the same. Then we'll move to the right. To see the video on motion, types of motions, then we'll move to the next topic.
Hi, today I'm here to discuss with you the various types of motion. The whole world is in some kind of motion. For example, a cyclist going on a straight road, the blades of a moving fan, a child on a swing. They are all regarded as being in motion. But we can see there is some difference in their motion. The cyclist is moving nearly along a straight line. The blades of the fan are going round and round about its central rod. And the child? The child is swinging to and fro in a regular manner. We thus realize that motion can be of different types. So what are the types? I begin with rectilinear motion. An object is said to have a rectilinear motion if the changes in its position are all along a straight line path. See these examples. School children marching on the Rajpath on the Republic Day. Motion of a falling stone. A motorist going straight on a straight road. Striker. Motion of a striker in a game of carom. In all these cases, the objects concerned are moving along a straight path. We call such a motion as the rectilinear motion. Next, curvilinear motion. When an object moves from one position to another along a curved line, the object is said to have a curvilinear motion. Let us see the examples.
Right.
A boy is standing on the bank of a river or a pond and he's throwing a stone into it. So how does the stone move? It moves into a curvilinear motion. Another one, a bus moving uphill on a zigzag road. The motion of the tip of pen while writing are examples of curvilinear motion.
It's very simple. See, means
rotation and revolution.
So
let us explore one at
the first one is translatory motion. We have seen. This is second type. We'll see later. Discuss about this.
Rotation. An object is said to have a rotational motion if it keeps on moving round and round,
just like
or keeps on spinning about some definite line or axis without changing its place. Examples. Look at the blades of a moving fan. They are seen as moving but are clearly not moving along a straight line path. A potter's wheel, the wheel of a sewing machine, a child on a merry-go-round.
See, merry-go-round is very familiar.
In all these cases, the objects concerned are changing their positions with time, but are still effectively at the same place. We call all such motions as rotatory motions. What about the motion of the moon around the earth, or the earth around the sun, or the motion of the hours and seconds hand of a wall clock? Is it rotation? It is revolution. So what is revolution? The motion of an object moving around a central point, changing its position continuously, usually following a nearly circular path, is revolution. Here, the objects concerned are not moving in a straight line, but are still changing their positions continuously. They are moving in a nearly circular path about a central point. Sometimes, an object keeps on moving in a perfectly circular path. For example, if a ball is tied to the end of a string and the string is whirled round and round, the ball moves in a circular path. We then call such a motion as a circular motion. Periodic and non-periodic motions. This is interesting. Listen carefully. The type of motion which repeats itself after a regular interval of time is periodic motion. Examples: the motion of the earth as it revolves around the sun once every year. Motion of the hands of a clock, which repeats itself after a regular interval of time, like 60 seconds, 60 minutes, etc. And non-periodic motion. There must be only 2 points we should consider. Either the motion does not repeat itself, or does the repetitions in a random, irregular manner. Examples: when a person speaks, like I'm talking now, so my lips are moving. This movement is as long as I am speaking. When I stop, there is no movement of the lips. The movement occurs again when I... Thus, the movement of the lips may get repeated, but there is no regularity of time here. Similarly, a ball rolled on a floor keeps on moving for a while, but does not repeat its motion after it stops.
Right. See.
Oscillatory motion. An object is said to have an oscillatory motion if it moves to and fro along the same path in a regular periodic way.
You can see the watch also, wall clock, gold wall clock.
Examples:
Swinger.
The swinging pendulum of a clock, a child moving on a swing, a ringing temple bell.
Temple bell also.
It moves back and forth between the 2 points along the same path. Such a motion can be observed in a suspended object for which one end of the suspending thread, wire, or rod is fixed. Here, the object moves as a whole and there is no change in the shape or the size of the object.
Right. So these are the different types of motions which we come across in our day-to-day life, right? So in which what we discussed is about translatory motion. Next comes rotatory motion. Already we seen in the video, rotatory motion. You know, the top. So a spinning top. Make the top to rotate with the thread, rope, and it's spin. So the rotation of the top will give the rotatory motion. A spinning top, a wheel of moving vehicle, wheel, a hand of the clock, right? The motion of object rotates about a fixed axis or fixed point is called rotatory motion. Okay. The second type. Third type you can see here. Oscillatory motion. To and fro, here and here. When you see the wall clock, old wall clock. So where you can see the belt, it moves here and there. Pendulum. So to and fro motion of called oscillatory motion. The motion of pendulum of a clock. The motion of needle of sewing machine. When you see the machine, the needle will move up and down like this. Up and down also comes under to and fro. The motion of the piston of an engine. In any vehicle, there is a piston which it moves up and down like this. About a fixed point and to and fro. Right? So pendulum of wall clock, swinging cradle. Swinging cradle also example of the oscillatory motion. So this is the third type of motion what we have seen. Right? So translatory. In the translatory, there are two types are there. Then that is rotatory, oscillatory, and periodic motion. Another one. Periodic means about same. For example, see Earth. Earth is revolving around the sun from last 400 million years continuously. That is called periodic. Continuously along the same path without changing the position. Right? Moon is revolving around the Earth continuously. So the motion repeats at regular intervals is called periodic motion. The motion of the Earth around the sun. Best example for the periodic. Periodic is nothing but continuous. Right? Got it? Then random motion. Random is nothing but irregular. For example, mosquitoes are there. How mosquitoes will move? There is no any direction. They move randomly, like irregularly. Or honeybee. Or fish in the water. They are random motion. Random is irregular. There is no particular path. Neither they are going in a straight line, nor they are going in circular path, nor they are moving to and fro. They move irregularly. Random is also called irregular motion. Right? That is. Next, circular motion. Another important one. Circular motion. The motion special case, you can see. You take one thread, tie stone to that and rotate. Whirling of stone. It will follows the circular motion. Moving around the same path with a radius, same radius. Circle. Is a special case of rotatory motion. It's also rotatory. Special case of rotatory motion in which the distance from the axis to the rotation axis is same. That is, radius is constant. If radius is constant, we get the perfect circle. Let's see how is he whirling the stone. So these are the 6 types of motions we'll come across in our day-to-day life. Of course, there are so many other are there. We'll discuss in the coming class. So types of motions, what is motion, and what are the types of motions we have seen today. Then when the body is in motion, we'll come across some terms. Terms related to motion, we'll discuss in the next class. So go through all this first: translatory motion, rotatory motion, oscillatory motion, periodic motion, random motion, and circular motion. So 6 types of motions. You can do this as a project also. Prepare a nice chart with the different photographs collecting from Google, different types of motions and their examples and the pictures. So take it as a weekend project and do the project, all the 6 types of motions, and try to understand the concept here. All are going on. We are not discussing about the cause here. Only discussing about the motion is called kinematics. Right? In next class, we'll discuss more about the what are the terms we'll come across when your body is in motion. When body is in motion, what type of words will come across? Like distance, displacement, right? Distance, displacement, velocity, speed, acceleration, deceleration, time, all those things will come across for a moving body. Right? So today's home task: define motion and rest, give examples. Or you can write as a name the types of motions also. Maintain the notes properly every day and make sure that the date should be there for the today's topic, date and the topic name, and write the important points and give for the signature to your respective teachers. right? So that's all for today. So thank you very much, students. Have a wonderful day. Thank you.